In lesson 5-1, we're going to estimate sums, differences, products, and quotients of fractions and mixed numbers. So going through all of our words here, sums means we're adding, differences subtracting, products we're multiplying, and quotients we're dividing. So while you're following along with your notes here in Moodle, you should be copying everything that you see that I'm doing on the screen. A key word in today's lesson is the fact that we're going to be estimating. So you're not going to have any exact answers today. We're just estimating, which will help us to come up with reasonable answers. So it's kind of a way for us to check our answers when working with fractions. I'll be using the word compatible numbers quite often, and that usually refers to denominators or finding two numbers that work really well together, even if the estimation really doesn't make sense. We want to find compatible numbers to make it easy for us. So for example 1, this is what I'll have you do for homework and for all of these problems that we do. We're always going to copy the original problem, so 5 1/4 plus 3 5/8. That way we get it into your own handwriting and your own size. So everything you see me do, I'm going to have you copy it. Again, we are estimating with mixed numbers. These are mixed numbers because we have a whole number and a fraction all together. So 5 1/4 is really close to 5, and we're adding, and 3 5/8. Well, 5/8, 4/8 is equal to a half. So 5/8 is more than a half, and whenever we have more than a half, we're going to round up. So we're going to get 4, and so the sum is about 9. Again, we are estimating, so there's no way to really check this. This is actually a way for us to check the actual answer. In later lessons, we'll actually be doing this problem where we're adding 5 1/4 plus 3 5/8. And we know that using estimation, we should get an answer close to 9. Example number 2, 7 3/4. So let's write that down. 7 3/4 times 1 7/8. Again, 7 3/4 is more than half. 3/4 is more than half, so we're going to round that up to 8. And 7/8 is really close to the next whole, so we're going to say that's 2. And 8 times 2 is 16. And that is our estimate. Again, we're not actually solving these problems. It does say to estimate, so that's what we're doing. So in the future, when we do solve this problem, we could do a quick estimate in our heads, and we just do, 8 times 2 is 16. Our answer should be close to 16. But when we actually look at the two numbers, with 7 3/4, we had to round up to 8, and 1 7/8, we rounded up to 2. So we rounded up twice. We should know that the real answer is going to be less than 16 when we actually do this problem. So that's kind of something I want you to keep in mind also, is which way are you rounding? If you round both up, your answer should be down. If you round both down, your answer should be up. And if you round one up and one down, you should be pretty close to your exact answer. All right, for example number 3, it says estimate. Again, estimate with fractions. So we're doing 1/3 plus 4/7. And again, we're not being asked here to find the actual answer. So in this case, 1/3 is actually really close to 0. So we're just going to round it down to 0. And 4/7, well, I know if the 7 was an 8, it would be 1/2. So in this case, you can actually go ahead and round that to 1/2. And if you don't realize that, at least you should realize that 4/7 is more than a half. And so 4/7 you could actually round to 1/2 or just 1. And so for our answer, you should get either 1/2 or 1. Because 0 plus 1/2 is 1/2, and 0 plus 1 is 1. So I would accept either of those types of answers. And maybe the 1 is actually a little bit closer, because 1/3 is obviously more than 0. So we round it down, and then you can actually round up to 1, and we're going to get pretty close. Okay, again, estimate. So we'll copy that down. 5/8 minus 1/4. Possibly what you can notice here is 5/8 is really close to a half. So you could say 1/2 minus 1/4. And if you think of a half as 50 cents and you think of a fourth as a quarter, you'll be left with a quarter. Now that's actually a really close estimate because we didn't round one of the two numbers. Again, what you could think about is this is a half and this is 0, and you could do 1/2 minus 0 equals 1/2. That's also another option for you there. So again, we're just estimating, and when you estimate, the idea is to be as close as you can to the right answer, but to be in the ballpark. So before, when we were dealing with mixed numbers, you realize I was going to the nearest whole. But here, when I'm only working with fractions, I don't have any whole numbers. Now, whenever you have just fractions, it's probably more appropriate to go to the nearest half. So back here, when we were using whole numbers, notice I was going all the way to 8 and all the way to 2, and I was trying to get whole numbers. Well, now we don't have any whole numbers like in this problem. We didn't have any whole numbers, so I'm trying to go to the nearest half. 0 is closer, and a half is closer. And for this problem, a half is closer than 1, and 1/4 is fine the way it is, or you could go to 0, and that would be fine also. Okay, so estimate, I see that we're dividing, so I'm going to copy the problem, 5/6 divided by 4/5. Okay, now we don't even know how to divide fractions yet, so again, remember, we're just estimating, so 5/6 is really close to 1, divided by 4/5 is close to 1, and so 1 divided by 1 is just 1. So I know that when I really divide this problem, I should get an answer really close to 1. All right, so now we're going to get into this compatible number phrase. So we're going to do 3/4 of 21. Okay, now when we talk about compatible numbers, what we're talking about is the denominator and the number over there. Those numbers should be compatible. And when I say compatible, they should be multiples of each other. So right now, 21 is not a multiple of 4, but there's a number really close to 21 that is. So I'm going to change this to 3/4 times 20. Okay, so now if you need to, you could think of it as like a little picture here, and we're going to cut it into fourths because we have 3/4. And when you think of 20, you know you're going to have 5 in each section. So 5, 10, 15, 20. And we have 3/4. So that'd be this one, and this one. And we notice there's 5, 10, 15 in 3 of the sections. So 3/4 of 20 is 15. And this is still an estimate because 21 is the only thing we rounded. We rounded to 20. So we know that the answer is actually going to be really close to this because we didn't round this very much. So again, how to think about this without a picture? Well, 4 times 5 is 20. So I know that my groups are of 5, and you have 3 groups. So 3 times 5 is 15. So you could kind of do 4 times 5 is 20. So 3 times 5 is your answer, 15. If you kind of set it up like that. You could also make an equivalent fraction. So 4 times 5 is 20, and 3 times 5 is 15. And 15 is the number that we're looking for. So it's kind of some ways so you can show your work. Here's one way is with a picture. Here's another way using numbers. For your notes, you should have all of this, and then you can decide how you want it to look when you're doing your homework. For example 7, so we'll copy the problem, 15 and 8/9 divided by 3 2/5. Okay, so 15 and 8/9. Well, that number is really close to 16, so let's just make it a 16. And we're going to divide by 3 2/5. So I would normally round this down to 3, but 16 is not divisible by 3. And remember, we want to use compatible numbers. So think of a number that is close to 3 2/5, but can divide into 16. Well, that number would be 4. And 16 divided by 4 is 4. And so even though we normally wouldn't round 3 2/5 to 4, in this problem we'll go ahead and do that because we want to be able to estimate quickly to find out what a viable solution would be. So, you know, if you're looking at this problem later when we're actually going to solve these kinds of problems, you can just look at this and say, well, 16 divided by 4 is 4, so the answer should be really close to 4, and then you can go ahead and work it out. All right, for our last example today, Mrs. Loy's front room is 29 1/4 feet long. So I'm going to write that down, 29 1/4. She wants to find a rug that is about 4/5 the length of the room. Whenever you see of, that kind of tells you that we should be multiplying. So I'm going to go ahead and say times 4/5. So about how long should the room be? Well, this is kind of like this example that we just did right here. I have a fraction and I have a number. And actually this time we have a mixed number, but that's okay. Think about what number is compatible with 5. That's close to 29 1/4. Well, 25, 5 times 5 is 25, but 25 is kind of further. So let's go to the next one. 30, 5 times 6 is 30. So let's change this to a 30 times 4/5. And I would multiply 5 times 6, so let's multiply 4 times 6. And 4 times 6 is 24. And the units up here are feet, so 24 feet long. Again, this is an estimate, but we know that our answer should be pretty close to that because we didn't round it very far, just from 29 1/4 to 30. So the answer should be close to about 24 feet long because she wants the rug that's about 4/5 the length of the room. Again, that is our last example for today. So if you'd like to watch some more examples, be sure to check the online tutors that I have loaded on Moodle for lesson 5-1. Or for help with homework, you could check the step-by-step homework helper that will actually walk you through all of the odd-numbered problems and how to do it, along with what work you should be showing. So good luck with lesson 5-1, estimating with fractions.